Ladies and gentlemen, parallel lines. Was anybody in geometry last year? Maybe currently this year? What are parallel lines?
Two lines that never touch.
Two lines that never touch, they never intersect. What would that mean? If lines go forever and they never touch, they never intersect, that means they're going in the same direction. That means they're never ending. They're going in the same direction, they have the same steepness. If they have the same steepness, they have the same slope. That's exactly right. So parallel lines, like if I were to draw two lines just right here on the paper, and they're traveling in the same direction, and they never cross, those are parallel, right? That didn't look too parallel. But anyways, you guys understand what I'm saying. So we're not going to be looking at pictures and deciding if the lines are crooked or straight that they won't cross. We're going to look at it algebraically. So if we know that parallel lines have the same steepness, which means they have the same slope, we're going to take a look at two equations. And if they are in slope-intercept form, y equals mx plus b, or point slope form, y minus y1 equals m, parenthesis x minus x1, if it's in either of those forms, you could clearly see your m value. Right here, my m value is 2/3. Right here, my m value is -2. Right here, my m value is 1/2. What's the m value right here? It's not 2. It's actually -2, right? The only way you could see the m value is if you have y equals mx plus b. And right here you have a negative, right? So you have to change the way it looks first. You have to make it look like slope-intercept form or point slope form to be able to look at your m safely. So number one, we really do have the same slope, 2/3 on both of them. These are definitely parallel. These are all examples of parallel lines. This one's in slope-intercept form. The m value is -2. Over here, you'd have to divide by -1, divide by -1, divide by -1. And you'd have the new equation, y equals -2x minus 4. And of course, now you could see that the m value, -2, is exactly the same as that m value, -2. So same exact m value, another example of parallel lines. Numbers 3 and 4. Number 3 is in point slope form. Point slope form, both of them have the slope 1/2. This is point slope form, the slope is 1/2. This is in what form? It's actually in no form yet. What do I need to do to get it in slope-intercept form? Divide by 2. So if we divide everything by 2, which I hope you guys do on your paper right now, y is going to equal 1/2 x minus 7. And now you could say, okay, this point slope form equation has the slope 1/2. This slope-intercept form equation has the slope 1/2, and that's why they're parallel. Do we understand parallel lines? Yes. Same slope. Parallel, same slope. Let's move on. Flip that paper over. Back here, we're dealing with perpendicular lines. Now, perpendicular lines are unlike parallel. Parallel never intersect. Perpendicular definitely intersect each other. They cross each other. And they actually are more specific than just crossing. They cross to form perfect corners, perfect 90-degree angles, right? So more importantly, when we compare an equation that's in slope-intercept form or point slope form with another equation, if the slopes are opposite reciprocals of each other, then we could conclude that they're perpendicular lines. Again, perpendicular lines have opposite reciprocal m values, opposite reciprocal slopes. Now, what does that mean, opposite reciprocal? That means you're going to change the sign and flip the fraction. Okay, change the sign and flip the fraction. So all of these are examples of perpendicular lines. So this is definitely in y equals mx plus b. What's the m value on that first one? 2/3. Now, if I were to do an opposite reciprocal slope, if I changed it to a negative and then flipped the fraction, what would it say? It would say -3/2. So this is definitely perpendicular, not parallel. Does that make sense? All of these are examples of perpendicular slopes. All of these slopes are opposite reciprocal slopes of each other. Okay? So even this next one, if you made it look like a fraction, and then if you were to change it to a positive and then flip this over, it would be a positive 1/2, and that's exactly what we have over here. So that's another example of a perpendicular slope. What if I were to take this 1/3, change it to positive, and then flip it? What would it say? It'd say 3/1, which is 3. So that's another example of a perpendicular line right there. They have the same, opposite reciprocal slopes. Now, in order for you to see the slope of this one, it has to be in slope-intercept form. So we would divide by -3, divide by -3, divide by -3, and we'd have a new equation, y equals -2/3 x plus 4. So we could clearly see the m is 3/2 on the first one, and the m is negative 2/3 on the second one, and that is an opposite reciprocal slope of each other, right? So those are all examples of perpendicular lines. So again, the important detail is that it must be in y equals mx plus b form or in point slope form in order for you to see the m values. If they don't look like slope-intercept, you're not going to be able to see that m. If they're not in point slope, you're not going to be able to see that m. So please make sure that the equation is first in slope-intercept or point slope before you start deciding whether they're parallel or perpendicular, or maybe neither, okay? And this is where I want you guys to finally try. I apologize for the long lesson, but we have 6 examples right here, and one of them is kind of very tricky, but I'm going to pause it right now, work with the partner, and decide whether this equation is parallel to this equation, or if it's perpendicular, or if it's neither. Go for it. So number 1 here, in order for us to compare slopes, I need to make sure that they're both in y equals mx plus b form, which they are. So the first one has the slope 1/2, the second one has the slope -2. Or if you wanted it in the form of a fraction, you could put it over 1, right? Now, are they identical? Is this one exactly the same as this one? No, so we know that they are not parallel. So the next question is, are they perpendicular? So if I take this slope right here, and if I change the sign to a negative, and then change the 1/2 and make it a 2/1 with a negative in front, won't it be this one right here? Negative 2/1, right? So these are absolutely perpendicular. I want to put perp as an abbreviation. Okay, so that's definitely perpendicular. Let's look at the next one. Could I see the slope on this equation right here? Yes, what's the slope on this equation?
1/3.
It's 1/3. Could I see the slope on this equation right here?
No.
No, not yet, right? You have to get rid of that -3 by dividing by -3, dividing by -3, dividing by -3. And remember, there's an invisible -1 in front of that x. So when you rewrite your equation, you're going to get y equals +1 over +3 with an x and +8/3. And who cares about the b value? All we care about right now is the m value is 1/3, and over here the m value is 1/3. So it is the same exact slope. So what do we say? Parallel. So I want to put PAR, pair, as parallel, abbreviation. So in order to see the slope, you need to compare slopes. But in order to compare them, you need to have it either in point slope form or slope-intercept form. I had a student earlier in the day say, wait, well, this is standard form. I didn't even talk about standard form, but if you know that, that's great. That's from Algebra 1. But this, you can't see the m value. You have to change it to slope-intercept form. So let's get y by itself by subtracting 2x and subtracting 2x and then rewriting the whole thing, bless you. 3y equals -2x plus 12. My final step would be to divide by 3, divide by 3, divide by 3, and I will have y equaling -2/3 x plus 4. So I now know that this equation has the m value of -2/3. And on the other one, I need to get y by itself, so I divide by 3, divide by 3, divide by 3. So I get y equals +2/3 x plus 5/3. I don't even care about the b value. But what I do want to do is compare my m value, my slope, which is -2/3, compared to +2/3 m value. And these are definitely not the same. One's negative, one's positive. And they're definitely not opposite reciprocals. They're just opposites. So these are not parallel. These are not perpendicular. What do we say? Neither. I'm going to put NE for neither, abbreviating. Number 4. Could I see my slope on this first equation? What is my slope? The 1 in front of the x, right? Or you could say 1/1. How about my slope over here? That's -1/1, right? -1/1. So are these the same exact slope? No, they're not the same exact slope, so they're not parallel, right? One's positive, one's negative. The question is, are they opposite reciprocal slopes?
Yes.
Yes, they are. If I take the 1/1 and change the sign and then flip the 1/1, it's going to say -1/1, and that's exactly what this says. So these are definitely perpendicular. Perp. Okay, number 5. Could I see the slope of my first equation?
Yes.
What's my slope?
2/3.
2/3. Could I find my slope of my second one? Yes. How do I do that? Divide by 3. Divide by 3. Divide by 3. So on my second equation, I now have y equals, my slope is 2/3 x plus 5. Okay, so my slope on my second one is also 2/3. So what do I say this is right here? Parallel or perpendicular? Are these the same exact slope? Yes. Now if you say parallel, you're technically wrong.
It's not the same.
Because it's the same exact line, right? I know. I don't even remember if I did this on purpose or if this was a total accident. But, I mean, what everybody's going to think is parallel, but they're not parallel. Why not? Because this is the same exact line as that one. And in order for there to be two parallel lines, you have to have two different lines. This one says y equals 2/3 x plus 5. This one also says y equals 2/3 x plus 5. So you're talking about the same exact line. So there's a trick question where you could just say neither. I mean, first reaction's parallel, but it's actually neither. Why not? Because it's the same line. Last one. Let's divide by -1 to get the y by itself. Divide by -1. So you get y equals -x, and the other one is y equals +x. So the slope on the first one is -1 over 1. The b value is 0. It doesn't have a plus b. And this one's +1 over 1. So what are these slopes? Are these the same exact slope? Or are they negative reciprocal slopes?
Negative.
Yep, negative reciprocal. They're opposite reciprocal slopes, which means that these two lines are perpendicular. Perpendicular. So I hope this helps. Please expect to see some of these questions on the quiz Friday. And we'll continue with this other part with these extra different types of problems tomorrow.